Oh dear, I forgot to turn on the camera. There we are. Hello. How is it going? Hope everything works correctly. I have no idea. Hang on, let me listen in. Yeah, all right. Seems to be fine. Cool. Just a few things to start. I like to mention I have a new YouTube video out as every Friday. This one is about Game Boy cartridges and how to read the header information to do it. Looks and sounds fine. Excellent. Thank you, Coca Joe. So give this one a watch. It was fun making it. And then as a second thing, I released the Alpha 3 of the of the Game Boy Assembler to Kofi supporters. So if you want access to the source code, check out the Kofi page. The code for all the videos, like for example reading Game Boy headers and stuff like that, is available for one-time donations, while the assembler source code and source code for other projects that I'm working on, well, at the moment it's just the Game Boy Assembler, but anyways, is available for monthly subscribers. And that's about it. So let's start with Alpha 4, right? We do my patent pending way of version control. So we are in Alpha 4. Built. Excellent. Okay. Will this refresh? It has. Fantastic. So the goal for Alpha 4, let's think about this for a second because I haven't thought about it much. Okay, let me turn off my mug here. Shoot, I forgot to bring up water. Okay, whatever. I have to get a quick break at some point and get a glass of water and everything. I thought I was set up for everything. Apparently not. I'm a bit... Anyways. Still tired. So my goal was at least to recognize all the keywords, right, for the assembler. So all the necessary instructions like load, I don't know, jump, all this kind of thing. So basically just recognize the keywords. And then maybe being able to read operands. But we'll see how far we get into that. I have so many other ideas that I want to implement here, but it will all take time, right? It would be nice to have some kind of profiling at some point. I mean, we have this parsing stats, right, that at least shows the overall parsing time, which, is okay, but I would like something a bit more fine-grained. I would like to have something for the arenas, which shows me the maximum amount of memory that has been used and all this kind of stuff. So yeah, lots to do, but let's continue with keywords. Or we can start with this. Symbols table should be a global like dictionary, right? And then I have this right meta program to add all the keywords to the table. Let's get something small out first, out of the way, right? Global symbols table. Let's do that. Sort of to wake up, because I'm still not fully awake. Okay, so we have the hash map right here, right? Okay, and then we have symbols, right? Those are the keywords. For that we have label definitions. All right, that is all right. I actually want to extend that at some point, but I'm jumping ahead. Okay, symbol types can be keywords. Okay. So what is the symbols table then? At the moment, I just have this hash map and call it symbols. Right, I see. Okay. So what we should do is have something here, void init global symbols table, right? And then we probably have some functions that can deal with the symbols table. We probably want the arena, right? And then we just want to hoist out this stuff right here. Yeah. Right. So we have a hash map. We create a new hash map with the arena. This is the symbol bucket size, right? We could do it like this. Symbol table bucket size. Bucket count, right? That's better. So we have these symbols. Okay, so this will just be a hash map T of G symbols table. Initialize it to null. Write last window error, and then we return the exit code. No, in this instance, we actually just want to full-blown exit, right? So write last window error and exit. I really have to think about this a bit more at some point, all these exit scenarios. Shoot, what was the... It wants an arena and a format. Okay. Arena... failed to create global symbols table. That's fine, right? Okay, and this probably should go into this one right here, into G symbols table, right? And we want to make sure that in the beginning it is actually null. Right, we don't want to initialize it twice. Okay. So let's move this one into the C file. Right. We can do it static, doesn't really matter because we only have one C file anyways, so one code compilation unit, but whatever. So this is our definition, right? So, and then here we can just say init global symbols table, right? Arena. Is it symbols or symbol table? I already don't know. Symbols. Okay. Jeez. Okay, and this is how we said we're going to insert a symbol. Doesn't that happen in the parser already anyways? I remember we already implemented how to... Yeah, this whole thing. And I wanted to think about something to see how I can split it out from here. Right. Okay, well, so first of all, we don't need the symbols pointer anymore, right? So if I build this, it should show me all the errors, right, of where it was used. Okay, we don't need this, right? So this also doesn't need symbols anymore. The new tokenizer. There we go. 151. We check that symbols is not null, right? Don't need to do that anymore. Okay, and then in parser, right. Okay, so at the moment I'm just going to pass in the global symbols table, but I will have some functions that deal with that, right? So I don't have to use it directly. And here as well, this would be G symbols table, right? Okay, and on 2.7, right, we no longer need to pass in this. Okay, cool. Excellent. Okay, so we have a global symbols table now, and I said I kind of want functions to have for this stuff, right? So like adding symbols. Essentially, this needs to be broken down into like nicer parts so we don't have to repeat that code over and over, right? Okay. I think what I can do is have something like this, right? So we have a Boolean, and then say insert symbol, right? Insert new symbol. This will return true or false whether the insert operation has succeeded or not, right? And then here, I can actually return the symbol, because as far as I'm seeing, I need the symbol no matter what, right? So if I create a new symbol, wait, do I actually need it? I mean, I do want to return it, just in case I want to do something with it, right? I want to insert something. Yeah, that's okay. That's okay. Right, but I have... Okay. I think I need a bit more specialized ways of doing this. So instead of just saying add new symbol, I really need something like add, add a new label, and then just pass in the token. Probably. And then I can see if I can split it out further. Okay. Add new label definition. Add label definition. Insert label definition. And then we want to pass in the token, I suppose. But then it kind of needs to rely on the tokenizer. That should be alright. Right. Let's just add it and see what happens. Maybe this shouldn't really be in base, but rather in parsing. Yeah, let's move that. Let's move it. Source base symbols, right? Let's move that to parsing. And then in the main, we're gonna do parsing and move it after the tokens. Okay. Right, so we assert that token is not null, and we can just copy this, right? So we still need to copy the token, make a proper string out of it, right? Then I'm getting the hashmap item with hashmap insert value, which is now using the global table. So this is still the right thing to do, right? And then if the value is 0, we indeed add a new item. We can change this around, right? Just so it's a bit easier to read. And then so then we say symbol is this thing right here. It's a bit shit. Can I do this somehow differently? Wait, I can't really do that. I would need a pointer of a pointer, right? Which is also nonsense. I don't want to do that. And I do not want to copy the whole symbol type. Ugh. You know what? Yeah, struct, that's a fairly small struct, right? So might as well do that. And then I could have a macro saying and then x dot success is success. Okay, so that means we have an insert result, right? It's fairly short-lived anyways. And then we can say result success equals B32 failed. Failure, I think I called it. Oh, geez. Failure, yeah. Okay. There we go. And result symbol is this one right here. Okay. And then return result. Cool. This is a new definition, right? So we add it to the dictionary. Don't know what to do here when there's a failure, so we leave that for now. I really need to think about more failure conditions and stuff. You know what? I can actually just make it a hard exit for now, right? And then we think about this a little bit more later on how to deal with that stuff. I would kind of like to reduce failure points, but I don't know how to do it yet. So, yeah. Oh, I need the tokenizer as well. Okay. Fine. So this would be tokenizer arena, right? Fail to add dot this to the dictionary slash n, I suppose, and that is identifier length and identifier base, right? Okay, we allocate a new space for the symbol type, right? So we have the symbol right here. If this failed, we need to do something as well. Fail to allocate space for, right? Then we have a label definition. Okay, cool. Again, I mean, if this failed, this will fail as well. So I'm not sure what I'm doing here. Yeah, I really need to rethink this a little bit. Okay, line column position, right? Item value is the symbol, that is fine. And then we can say result success equals B32 success, and result symbol is the symbol, right? And then we just return the result. Okay, cool. So now in parser C, this whole thing, so we chill, we chill. We still check that the token length is 0 here because we do not want to add empty tokens. That is fine, right? Although, oh yeah, empty labels can happen, true, because you can just have the colons, right, without anything in front of them. So, but this whole code, right, and this now becomes, so, insert result equals insert label definition, right? Pass in the tokenizer and pass in the token. And then if is insert success result, we do this, otherwise we report an error. So at the moment, we don't really need to do anything else. Right? Probably not. So it would probably be good to have a is failure, is insert failure thing. And then I just need to say result symbol, right? Oh, I need the identifier, which I don't have. Ah, shoot. How do I get the identifier now? It's not stored anywhere on the symbol, no. I mean, the crude way to do this would be to say, well, just add the identifier, right? Whatever. Eh, that kind of works. Okay, so then we want to define is insert failure, right? Then we have is failure x success. Let's call this is success. And then we just have is insert failure, right? And then the identifier here becomes result identifier. There we go. So if we build, of course we have a shit ton of errors. Why? Okay. I don't know why I just built again, but insert result followed by void is illegal. Come again? What? Oh, is it? Right. Success, I renamed is success, right? Is success. Okay. Tokenizer, undeclared identifier. Really? Oh my god, I had a typo. That's funny. Okay, whoops. Oh my lord. Now we have it. Okay, so, and if I run, no, that's not a good sign. Oh. What? Why took that so long? Okay, whatever. That was weird. Okay, so this code is now a little bit, easier to reason about, right? So we have a token length. We check the length of it, which is fine. I could put that potentially in here, but I don't know yet, you know. These arrow things could probably be separate function. And then even here in like a symbol thing, like this pattern of like creating a string copy, trying to insert it, and then checking whether it was already there or not can also be its own thing. Maybe just a macro doesn't necessarily need to be a function. I don't know yet, right? We'll see where it takes us. But that is for some other time. So we have a global symbols table, right? Now what I want is sort of a meta program, right? Meta is probably the wrong word, I don't know. But essentially, so if I look in the old assembler, what I had to do is, well, okay, let me put it this way. We need to add keywords, right? All the keywords that the assembler can recognize. So LD, add, whatever, right? And those all need to live in the same hash map as all the other symbols, right? That's the only way we can actually figure out. Well, it's not the only way, but you know, in this program right now, it is the only way to figure out whether a label, for example, has the same name as a keyword, right? Or if we want to recognize keywords. And you saw this here in the example code that I did, where I just added like the keyword swap, right? And that is essentially one way to do this. So allocate a arena, like allocate a symbol type, then basically call hashmap insert value, right? Calculate the hash, look in which kind of bucket we need to put it in, do like collision resolution and stuff like that. And I just could do that at the beginning of the program. So I could just say init keywords, right? And that now would loop over all the keywords that we have stored somewhere and try to add new symbols for it, right? But that's kind of slow. I thought what we could do, similar to what I did in the old one, is to have just put those things in the buckets directly in the initialization of the hash, right? So all of this already lives somewhere in memory. We have the hash calculated and everything. We know which kind of bucket it's getting into, right? So we can just add it like this, essentially. Hey yo, IO means life. Welcome back. So, and you essentially have to add a new entry or check all the new entries as soon as you add a new keyword, right? So if we like leave alias and data out, we kind of need to add those in there as well. So I figured what I could do is have a second program in here, like a generation program, right, that compiles before the main program, where we just have a little text file or something where we specify all the keywords and what's needed, right? The string values or whatever is necessary to make keywords work, right? I have to look a bit into that. So it just reads that text file, parses it out, and then spits out some C code that the other program can include, right? So what does a keyword actually need? So a keyword needs a symbol, right? So this symbol thing needs to live somewhere. And it has a keyword type, which is just an int, right? But it also needs a name, a string literal. Which also needs to live in the dictionary. How big? Okay. Let's see. Can I put this on the stack, right? These would live in program memory, the strings themselves. Then hash map entry. It's just the value. And the value itself is just a symbol type and a keyword. Well, it has label definition as a union in there, which maybe was not a good idea. Oh, it's just a pointer, never mind. All good. Let's see. Actually, hang on. Can I not use the debugger for this? Debug, right? And then I do this. And then I think it can show types. Hell yeah. So hash map item, 8 bytes. I mean, that I don't really need to calculate, right? That is nonsense. Those will live in memory anyways, regardless. So what I need is symbol, which is 16 bytes. And where's dictionary entry? Ah, that's a bit bigger. That's 24 bytes. And how many? How many keywords do I have? Okay, these are a bit more because I had like alternative names for everything. I don't know if I want to do that necessarily again. So it had like uppercase variants and lowercase variants. I'm just going to stick to lowercase variants this time. Okay. I don't want to calculate line counts. Oh man, come on. $61. Almost a kib. We have 1 megabytes. Oh, that's fine. Okay, cool. So what I wanted to do can actually work. Right. Let's do that then. So a generator program. So what do we call it? We call it, no, not new file. What I want is a new folder, and let's call it keyword gen. Why not, right? New file. And this is keywordgen.c. Okay. We'll kind of have the same flags as all of this, so let's just copy all of that, right? Do we need Windows? Probably. We need stb, which is one folder out, right? Yeah, let's leave that as well. We need Danilib for sure. We need strings. We need hash maps. We need the console. Do we need arrows? Actually, no, we don't. This program will terminate right away if it can't create the code file, right? That is a serious error. So, oh, what? What have I done? What? I'm confused. Why did I hit it twice? Okay, whatever. Right. Console, yes. Error, no. Source file, no. Parsing stats, no. Tokens, no. No. Dictionary we need. Right? Symbols. Ah, see, this is where I'm shooting myself in the foot, because symbols now needs tokens. But I just need the symbol types here. Okay, whatever. I mean, no harm done in including it. Doesn't matter, right? We don't need parser, and program.c we also don't need. We'll just put everything in here. So setup console. In a global error list, we no longer need, right? We have an exit code, that is fine. We need a new memory arena, that is also okay. Yep. And then okay. Right. Let's just integrate it into the bat script first to see that it actually is getting executed correctly before I do any sort of code, right? So let's have write output string, right? String literal. Hello there. Very creative. Okay, so in the bat file, so essentially what I need is build step before this, right? So we have set compile keyword gen. right? What would that need? Compiler flags. What are compiler flags? Special compiler flags, additional compiler flags. So these can all be the same. Okay. Compile. That is cool. Source files will be slightly different, right? So let's name this keyword gen source files. Link, common linker flags, special linker flags, linker libs. Common linker flags, special linker flags. Okay, the only thing that needs to change, I think, is linker libs, because we potentially don't want all of them, right? So keyword gen linker libs. And then the out executable file will be keyword gen executable file. Okay, and so keyword gen source files need to be set, and keyword gen linker libs, and keyword gen executable file. Okay. I'm wondering why I include user32lib, but I think it's for a message box in the beginning. If I can't initialize the console properly, I'm displaying a message box. Okay, fine. Right. And okay, so these source files will be keyword gen keyword gen.c. All right, and then I can have a special flag here. So let's say if percent no keyword gen, right? Or let's no keyword gen. Because maybe I want to build without, keyword generation the whole time. If it slows things down or whatever, I just want the option to disable it. So I'm gonna do something like this. What do? We just say echo Yeah, let's just do it this way. Building without keyword gen. Right. I always forget, is there an else in bat scripts? Bat script else. I don't usually do much bat scripting, so I always have to look things up. So there's if. Oh, there's else. Okay, nice. Okay, and then we are building keyword gen, right? So this will call compile keyword gen. Oh, come on. Did I not? There we go. Right, if something fails, we want to exit with our own error code. So this builds now the keyword gen, and now we can run, right? Running keyword generation. Call keyword gen executable file. I mean, we can do the same thing with this, but I think that's okay. So if you specifically have set no keyword gen, then we print out building without keyword gen, right? And then skip this whole step and just do the normal compile. However, if we're actually, you know, compiling with keyword gen, then we have to compile the keyword gen program, which is right here. And then we also want to run it, because that is the program that will generate the C file for us, which then this compile step will just include, right? So if I now go, did I still have Steam running? Oh well. Right, so if I now go, hang on. Do I want to unset all of this? I mean, I'm doing it here specifically, might as well do it. I'm not sure if I actually have to. Right. I don't know. Okay. Keyword gen exe. That seems all right to me. So if I now run build, well, that's a problem, isn't it? Okay. What's happening? Building keyword gen. Right. Keyword gen is failing because token needs source file. Oh my god. I don't... Mother... Okay. Okay, you know what? Let's just copy all of it then, right? Let's just give in. It's okay. We can. It's okay. It's okay. It's okay, right? If I keep telling that myself, it's true. Right? Let's just do that and figure that out later. Exit code success, undeclared identifier. Well, just make it 0 then, whatever. init keywords undefined. Where do I have init keywords? What are you on about? Oh, right. Wait. Oh, I included program C. Okay, I definitely don't want that. No, I didn't. Don't shoot. Oh, this failure was in the actual program. Never mind. But okay, so now you can see debug build, building keyword gen, right? It builds keyword gen.c and generating code. Then we're running keyword gen. Here's our console output. Hello there, right? And then we're building the actual program. So this is now the step where we can create the code file that we need, right? So what does this program need to do? So we want... Actually, maybe I should write out the code file that I'm expecting to see first, right? Also, what is the current process path of that program when it runs? Let me quickly copy some code from a different project. This one. So this just calls get current directory from Windows to get the current process directory. Uses the arena to allocate the string and then just return the string. Let's just add a new line like so. Oh. Okay, it is the debug folder. Right. So I'm wondering... I'm just wondering where to put the output files of the program. I don't necessarily want them... Really what I want is just the keyword.h file in here, which I then can include in the main program, right? So this should be running in the process where the build script is in, as opposed to the output folder. Oh, did I actually test build no keyword gen? Nice, okay, that works. Or I leave it in the output folder and then like awkwardly try to link to that. I mean, I could add it to the as a folder to look for the compile process, right? MSVC. Let's do this. Oh, come on. How do you add folders? No. I'm not making this up. There was a command line flag where you could add whole folders to look into for include files. But I can't find it right now. Ah! /I. Maybe an absolute path or a relative path. Nice. But isn't the process, the folder where the process is running from already one of those? Okay, you know what? Let's just create an output file, right? let's repurpose this. Okay. So I probably don't need get process directory. Create source file, right? strt file name, and then we want to make sure that file name base is not null and file name length is not null. We don't need to append like ever. And we have create file A, which is file name base, generic right, create always, file attribute normal. Okay, cool. That's what I want. Right. If output file is valid, do I need to do anything? No. We'll just create the file handle and return it. Whatever. Right. I mean, what I could do is like if actually I don't need that macro. If file handle is invalid file value, then I can just crash out of here, right? Memory arena t arena failed to create output file percent dot this file name wait. Uh-oh. I've been using that wrong. It will be something like this instead. This is not a great API, I know, but it is what it is right now. Here. Okay, file name length, file name base, right? That is create source file, and then we also want to open a file, right, where we have all the definitions that we want to read from. So that will be something like this. I think I can actually just use this function right here. Why not? I mean, it already exists, right? Whatever. Okay, so we want to open a source file, right? Source file t file. Let's call it input, right? Open source file. That needs the arena and the file name. So string literal. No, let's actually not do a string literal, right? Let's define them as globals right here, so I can change them easily if I need to. Okay, this goes down here. Right, and then static, we can say const whatever. Input file, right? String literal const. And we said we're gonna do yeah, see, so the input file is in here, so I really don't want this to run in the build output folder, so I'm just going to change that real quick. One thing that I can do is just say popd, right? So we're getting out of the build path. And then I can say call build path. Hang on, keyword gen. What? Oh, right. Input file. Okay. So now input file would be source. Keyword gen. Definitions. Right. Let's just call it definitions, whatever. Without a txt extension. Let's create that. No, actually, let's leave it out. CLS, no, CLS, build. Fail to open file source keyword gen definitions. The system cannot define the file specified. Cool. And now if we create one, definitions, source file is empty. Yes. Cool. Okay, so that works that I wanted to. I basically want to have it run in the same folder as the script, so I don't have to think about like weird paths or anything like that. So this is where we have all our definitions, and then we can put the output right here as well somewhere. Right? And then just include that in the program file. So let's say wait, can open source file fail in any other way? No, it always will return the right file. Right. Yeah, this is all a bit messy, but it's okay. It's okay. We can do this. Okay. So then we want to parse definitions file, right? And create output. So, and the output file will be, let's name this create output. Voids file, no, output, create output file, arena, and then we have output file. Okay. And that output file will be static const strt output file string literal const, and it will be in source keyword gen and keywords.h. There we go. And that is our output file. So now if we do build, right, we see that we see nothing. Oh, because the source file is empty, it doesn't do anything. Right. Okay. Build. There we go. And we have a keywords.h. Fantastic. Okay. So what do I want keywords h to look like? Right? I'll probably want these things. GB assembler, keywords h, right? And if, whoa. And then we can take all of these. So we want an enum like that, right? Which gives them like an integer or whatever. Then we can say keyword count. In case we ever need to figure out how many keywords we have. Should always be the last one. Then for all of these, I want a symbol type in memory. Right. So I want something like this, and whatever the count is, right? So and then in it all the symbols here. Okay, let's just make it with 1, right? Let's make it load. And include that in here. Cannot open. What? Oh, right, because you are in keyword gen. All right. That was a mistake. Oh, thank God, source file was empty. Okay, cool. Okay, keyword type redefinition, right? Okay, because I still have it in here. Which, okay, let's comment this out for now. Right, I cannot do that. Maybe I do need to create a C file as well. So I realized, just to explain, I'm basically just trying to figure out what the files should look like before I'm trying to implement the generation of it, right? So I'm just trying it with one keyword type for now, try to make it compile so I don't have to deal with that later, and then just specify what the definition file should look like, and then I can just add new keywords and all this code will be generated. Okay, so symbols needs the keyword thingy, which is fine. We can just say include keyword gen keywords.h, right? too many include files. Huh. So I probably have a circular dependency somewhere. Oh, nice. Maybe I shouldn't do that then. Oh my lord, no keyword gen. Okay, I need to figure out how to do this. But so label definition can still stay in symbols, right? We have keywords, keyword type. I mean, it's just an integer, right? Really, right? So I could just do this, right? It doesn't necessarily need to be tied to a type, right? So and then I can do this one as dot type equals symbol type keyword, and keyword equals, well, keyword type LD, right? Because at the moment we just have LD. I'm including myself. Oh my god. Ah. Yeah, that was not the brightest moment, was it? Okay, anyways, I need an enum with all the keyword types, so I can then use them throughout the code, right? I need to have the symbols somewhere in memory. They can just be static. And then I also need the G keyword symbols, right? And then we have G keyword names, right? And for that, I need string literal const, right? That would be just LD, for example. Right. Oh, dot keyword. Keyword type swap undeclared identifier. Yes, because we don't have one at the moment. That is perfectly fine. Okay, so these are all the names associated with the keyword enum, and these are all the symbols associated with the keyword enum. So now what we need to have is like functions that say init keywords, right? For example. And what we want is a memory arena T And so what needs to happen here? Well, that's not all we need, really. I just realized. Is it U64 or U32? U32. Hang on. What am I doing? I just need hash map entries, right? Yeah, I need hash map entries. So really, hash map entry has the key and the hash. It has the item. Okay, so we need the entry. And the item is the symbol, right? So the symbol. I don't know what the hash is, like 42, doesn't matter. That will be something that the program will be adding, so that will be generated, right? And then we have next equals 0 for now. And then item dot value equals does this work? Probably not. Okay. So this might work. It looks absolutely horrific. But luckily I don't need to type it out, right? Okay, sorry. What was it complaining about? It was complaining about swap. Yeah. Okay, we can remove this for now. Okay. So, and then we need something that adds this to the global hash map, right? So, hash map. Okay. And the way we do this. Okay, we have hash map dot Okay, so adding this to the hash map would just be something like this, right? We're just getting directly the bucket and just link to the entry structure right here. Right? And this would link to the symbol, which again is this. And we can get the slot right here, so we don't have to calculate it. I mean, we don't even have to do that. We can just hard code it, right? Can just say whatever the slot here is. Right. These we need to have in memory somewhere. The slot doesn't really matter. We just... Okay, so let's say I specify keyword LD, right, with the name LD. Yeah. I want a new keyword. Let's say I want alias, and the actual text will be this. And if I would later on want to attach like separate information, I could do that. But at the moment, it's just line by line, and we use the colon as a separator. So this will be the enum, and this will be the string, right? I think that's all right. So, and the reason why you want this generated as instead of like doing it hard-coded like that is because, you know, you might change the bucket size at some point, and then you would have to figure out which new slots to add to, and this generation program takes care of that. And because hash and everything else gets calculated during the generation time and not during the runtime of the program, this is like fairly cheap because we just add a bunch of addresses to, you know, to the right buckets when we start up the program. It's probably a little bit overkill, but I wanted to learn how to do it, so why not, right? Sorry, I know I've been a bit quiet today while I was doing stuff because I still keep like thinking on how to do this and how I want this to look like. But this seems all right. Now, but what about dictionaries, right? Why? That is a whole nother can of worms because that is arena based. But that's just a string that's pointing somewhere. It doesn't necessarily need to be a copy. It only needs to be a copy when you actually put it in there, right? So when it comes from a source file, that's why I'm doing the copy part. Actually, not even true. I do the copy before that, right? So really, I just need to put it somewhere in memory and then refer to the next thing. So that can just go into the arena. So that can just be done in like one go in the beginning. Essentially what you would do here is like allocate arena space for X amount of dictionary items and fill them up, right? That's fairly straightforward as well. So, and in this function, I do not want to refer to the globals because I don't know if the globals will change at some point or not, right? And because this is like generated outside of the usual program code, I want this to be like a bit more generic, I suppose. I don't know. Right, and the dictionary has a different arena. And then we have the first entry and the last entry, right? Yeah, okay. Yep. Okay, cool. Let's focus on the generation. So we open the definition file and then we need to parse the definition file, right? So we can do it similar with like tokenizers. It basically is the same principle as tokenizers. So we basically get 2 tokens out of this. So keyword definition. What does it have? It has a enum name, and it has a let's call it identifier, right? So this is going to be fairly simple. Keyword definition T, right? And then we have keyword definition get next keyword definition. We want the next keyword definition from the source file, right? So file, so assert file is not null, and file yeah, how did I do this? Get code point. It's probably overkill to do this with code points as well, but it's fine. Let's just try it out. But it's calling add source file error. Ugh. Okay, you know what? It's a simple keygen. Like, let's not assume that this is actually like UTF-8 or anything like that. Let's just keep it very simple because it's really, it is just for keywords, right? It doesn't need to be anything fancy. So I'm just going to read ASCII, whatever. Just read it byte by byte. So U8, actually, we have position, right? Position will be 0, so what I want is while file.base file, no, not dot, it's a pointer, right? So base position so as long as this is not null, we're doing something, right? And this is, well, we're starting out as the base, so let's do it with an arena, why not? Keyword definition T, whatever. Honestly, I won't even bother with like too much error handling and stuff like that because there's a file that is in my control, right? So I'm really not going to bother too much. So we're starting with the enum name. So enum name base is this base right here, right? And then keyword, we're just counting the length. So we're basically just gonna do current, right? And then we can do current equals this, right? We increment the position. And if current is not null, then we go ahead and if current is not colon, keyword num name length plus plus. But I kind of do want to. Ah, man. This is turning out more annoying than I wanted it to be. I mean, I'm including error anyways. Fine, okay, let's do get code point. Okay. Let's be nice. I can actually just copy a few things from here. right? Okay, I have to go quickly and let my dog out of the room, and that is a chance for me to get a coffee and then come back. So I'll be back in like 5 minutes, I think. Sorry about that. What? A bit more? Okay. How many? 10 minutes? Okay, I'll be back in 10 minutes. I've been told I need to take a break for 10 minutes. All right. I'll see you back in 10 minutes, and then we continue with this one. And I'm gonna do the proper tokenizing thing. All right. Okay. See you in 10 minutes. All right, I can be back a bit earlier. Surprise! Okay. I was trying to just hack this out really quick, right? But maybe I should put a bit more care into it. So let's do that, right? So we have the error thing, so we can actually initialize the global error list. That's fine. We probably want to print errors as well in this program, right? Let's be nice. So let's do something like init global error list. This one even has its own arena and everything, so let's see. Init global error list. I do this even before the arena, right? And then just gonna call print error. Okay. So we can do the same here. And actually, let's do B32. Has errors, right? Let's say get error count. Oh, no. And then return g error list and count. I mean, I don't really like getter functions like this, right? But since this is a global error list, I don't really know if I want to, like, you know, access the global without these functions. So let's just do that. And then get error count. Exit code is, well, if this is not null, then I don't know, 42. No, I don't know. Sure. It's just about printing the right exit code, or actually having an exit code at all. I mean, the exit code doesn't really matter, so we can probably do that. Actually, if this is not null, this will be true, so which will be 1, so exit code will be 1, otherwise exit code will be 0. So we can do that. Actually, and since we're adding it here, we might as well just do that, and then we do not need exit code at all up there, right? Okay. So init global error list we do before we allocate this stuff, right? So setup console, init global error list, then we will be doing whatever we need to do, right? And Yeah. Okay, let's not worry about the output file for now. So we're opening up a source file. We know this will be valid, otherwise the program will just close, right? And then let's just use whatever I've been using for the tokenizers here and just do exactly the same, right? So we just have the same patterns throughout, meaning yeah, we basically get the next string. You know what? We can actually do that. Yeah, so let's have read whitespace sequence. We have the keyword definitions. We return keyword definitions, which has the enum name and the identifier that we want to use. So that will remain. And actually, allocating this on the arena is a bit heavy-handed, but I'll see what I can do, right? I'll see what I can do. For now, let's not worry about this one, right? This is the outcome that we want. So what do we need? We need to skip over white space sequences, right? So we can actually do that. Is code point white space? That is fine. Yeah. So we might have leading white spaces or not, right? I don't want to like this program to fail just because of white space. Actually, it might also have white spaces here, right? However you want to, doesn't really matter. Important is just a sequence of characters like these, right? So then we have a bunch of white space, then we have the termination token here. We could also just use a comma, to be honest, right? Doesn't really matter. Let's make a comma. We can have another bunch of white spaces. We can have the name. We can have even more white spaces. Or, you know, and a new line always terminates the current line that we have right here. And we either have an item or we don't have an item, right? So we can also have a bunch of like new lines here that don't do anything, right? So we want to be able to deal with that as well. So how are we going to do that? So token, read whitespace sequence. Code point is whitespace. I think this one does not do anything for new lines, right? No, it's just... yeah. Read end of token. Oh, great. Spammer. Nice. How do you... I don't know how moderation works. I'm leaving that for my mod when he comes back. Okay, in anyways, so read end of token, it can be happening with either a new line with a white space. Well, that's not quite true, right? I don't... No, new line or white space or a comma, right? So let's have that as well. Or code point is comma. Okay, and then okay, we basically want to have a slimmed down tokenizer, right? So enum definition tokens. What kind of tokens can we have? Well, we can have definitions token white space, right? New line. We can have separator, right? And we can have an actual identifier, right? So those are our tokens. Definition token T, right? And then, well, we also have end of file, right? So, and that will be token 0. Okay, definition token, get next token, right? And what we're going to do is source file. We're going to do an assert for file. And then we're just going to do what we kind of have been doing in the actual tokenizer here as well. So except we do not need like position and all this kind of stuff. We don't care. It's not that deep, right? Right, so let's just copy this and then basically adjust it. Right. What am I doing? Brain work. Okay, so definition token type. Right. Definition token. Type def definition token T, right? Then we have a definition token type, right? We have a, so I have a length, which is correct. I need the length, but I also need the start, right? what? How did I do this? Oh, right here. Okay, fine. We can copy it. It's okay. Position, length, line, column. Fine. Definition token, right? Then we can actually just do this. Why do new work when we can just copy stuff, right? Why not? Position, column, line. We have the cone point. We swallow the cone point, right? We look at end of file, right? Then we have new line, except now it's a definition token type, so it's definition token type end of file. What is end of file? End of file is 0, right? Then we have new line like this, and white space is a definition token white space. Read white space sequence, okay. Right, I'm including the whole C file though, so this is super annoying. Oh, dear Lord. Maybe I need to treat this more like a completely separate project instead of trying to reuse the same file as here, you know. I kind of need to preface these with like keyword gen now, which is a bit annoying. Keyword gen read white space sequence. We don't have numbers. But we do have is if code point is a comma, right? Then we have token type is separator. So we got this, and this. And otherwise, it's just going to be this little thingy right here. Which is an identifier. Right. It's definition token type identifier, and what was the prefix? Keyword gen read end of token. And all of this is not needed. Okay. Length modifier. What was that for? Or for labels. Yeah, whatever. Yeah, we don't have that. Okay. Right, and then just return this token. And this token will be a definition token, right? Token. Just gonna do it this way, and all of these chunks will be token dot. All right, let's just create a new one on the stack. Why not? Doesn't really matter. Can also do this. Compiler will do the right thing anyways. Kakalakanja, are you there? By any chance? Probably not. Yeah, I don't know how to remove that message or ban that one, so if you could just do your magic, that would be nice. Thank you very much. I have not played around with the mod tool, so I don't even know how it works. Not a big deal, to be honest, but... Okay, so with this, we can now tokenize the file, right? So this is our tokenizer. We could put this in a separate file, but I'll just leave it in one for now. Although it gets it gets crowded quite quickly, doesn't it? Let's call this keyword tokenizer.c and put all the tokenizer stuff there. Maybe not .c. Let's do .h. Right. And then if endf gbassembler keyword gen tokenizer h. Disappeared on your end? Let's see. Yeah, I think the user got banned anyways already because it shows up as unknown user for me now. So thank you very much. um, okay, let me put this back because I can't see my pinned message anymore. But what do you mean I can't pin messages? Oh no, it's still there. Okay, I don't know what's up with Twitch chat at the moment, but whatever. Let's not waste more time on this. Okay. Okay, so this is the keyword tokenizer. That is fine. We also have it in a separate file right now. So now we can just say include keyword tokenizer.h, right? And then we can actually use that one. So now we want to make sense out of those token and get like the keyword definition out of it, right? So okay. Okay, here we just iterate over the tokens, right? And what we're going to do is, well, how are we doing this, right? We have a definition token, right? While token equals get next token in the source file. Dot type definition token type end of file. How the hell did I misspell token? What the hell? Oh my lord. This is so bad. Okay, so we're now just getting the next token, the next token, the next token, right? We iterate until we have an end of file, and then we just basically stop. If we have an end of file, then B32 false, right? Actually, failure, right? So if switch token type, right? definition token type white space, or new line, then we just, you know, skip so we're looking for an identifier, right? We're basically skipping white spaces and new lines until we get an identifier. Once we have an identifier, we know that identifier is the enum name, right? So we can then say definition enum name base equals token dot sorry. File base token position. That is the one, right? And then definition num name length equals token.length, right? Okay, then we need to look for a separator, right? And what we also need to look for then is another identifier, right? But this time without a new line involved. So basically, we need to skip white space if there is white space, and otherwise we expect this to be another a separator, right? So we call we're just getting the next token. If token type is equal to white space, and that is a white space sequence, right? So we can just skip it. So in this instance, we can just say token equals get next token, right? But only if it is a white space. Sorry, I should close this other file right here. So we have an identifier token, we skip white spaces and new lines and whatnot, right? So we have our first identifier, then we want to get the next token. Make sure the next token is not a white space. If it is a white space, we want to just skip to the token after that. Then that token should be a separator, right? So we have this token type separator. If it is not a separator, then that is an error, right? So to do report error, and we probably stop parsing in this moment because like this is a nonsensical file, right? So we can just stop there. Now, after we have gotten the separator, we need to read the next identifier. So we're just going to say, okay, give me the next token, right? And here the same thing. If the next token is a white space, then we're just going to skip it and read again, right? But then we're expecting an identifier. So if we get anything other than an identifier, then report an error and stop parsing because it is a nonsensical file, right? And then probably do the same thing again. But now we're expecting a new line, right? And if token type is not equal to new line, right? Then to do report error. Okay, so that is basically like the pattern. I know this is like really crude, but this is just like, you know, to get the definitions. That does not need to be a super nice program or anything right like that, right? So read expected separator, read expected identifier, right? And then read expected new line. Okay. If we do have a separator, we don't really need to do anything. If we have an expected identifier, then we do need to do something, because that identifier now will be identifier, right? So we get to the identifier base. We look in the token position and token length, right? So, and once we have all that, we can just say, okay, return no, this is a, okay, B32 success, right? Wait. This is black code. Right, and if it is anything else, then that is most likely an error. So to do report error, right? What is going on here? You belong to this. You down here belong to the switch. You down here belong to the while. And you down here. Wait, why do you belong to the while? My bad. So, and if it is an end of file token, right, at any point, we don't really care. We're already rooting out end of file here, right? And then we just okay, cool. And now the error stuff. Add source file error. Now this would actually be a token error, right? But a different kind of token error. So keyword tokenizer. Right. This would be keyword gen at token error. Nah, let's not bother with that. I just want to report errors directly here, right? So what is the error reporting mechanism? It's just going to be add error, right? So let's call that directly. What do we need? We need the file name, which is basically just file dot name, I think, right? If I'm not mistaken. File name. Should have just named it name. Yeah. Okay. File name. Then we have token.line. Token.column. Token.position. Missing separator after enum name. And we're going to say missing identifier after separator. Return B32 failure, right? And then down here, missing new line after keyword definition. B32 failure. Okay. And then here, whoa. What the hell was that? What did I do? Fingers, what did you do? What did you do? Invalid token. Let's just say invalid token, whatever. I don't want to bother too much with error messages because like this, I already spent way too much time on this program, honestly. Okay, so get next keyword definition, right? So now we can loop over the keyword definitions and actually get those output. So let's put that here. And now we can say, so open a source file, then we have a keyword definition, keyword def, right? We can leave it like that, whatever, doesn't really matter. Then we can say while is success, get next keyword definition in input with and keyword def, right? So as long as we have new keyword definitions, we're going to do something with them, right? And what are we going to do with them? Well, this is where we have to add them into the hash map, right? So we're going to have yeah. I think I do this as well. Let's just keep it simple. Whoops, not in here. Let's do that in here, right? We want the global dictionary, and we want a global symbol table. Okay. The global symbol table no, I wanted this here, right? Okay, bear with me. Yeah. Welcome back. I should have maybe done the string copy already in symbols. Nah. But I can do it down here. Arena. It's actually this. And this. And then definition enum name. I don't know why I put num name in there, but okay. Okay, so let's already give it a copy, right? And we do the same for identifier. Okay. And that means here I already have the copy, so I don't need to worry about this. Okay, but I need to add it to the hash map, right? So the global symbols table, we want to add the identifier. This is more annoying than I thought it would be. Okay, this information is all stored within the hash map, right? I can access that no matter what. This as well. My problem now is I need to store a bit more information in the generation, right? Because I also need the whole identifier stuff in there. So, if item value is not null, then we need to report an error because the item already exists, right? You can only define a keyword once, so this is definitely an error. So if it does not exist, okay, I'll not worry about the dictionary for now, but I also don't want to store the symbol there. No, we don't need that. So my idea was to populate the hash map and then iterate over it to then generate the code out of it. But looking at this, okay, I do need to add the symbol because I need the symbol, right? Let's do it this way. I need to hold on to the keyword definitions, so and then kind of loop through them. At the moment, it's like 60 keywords or something, but it could change. Okay. Oh, okay. Let me explain because you came late. This is like a separate program. It has nothing to do with the assembler itself. I basically want to have like a definition file for keywords, right? Where I can specify an enum name, I don't know, like this, and then an actual keyword name, like so, right? And have all the keywords in here, like in this structure, basically. And then this will generate this code out of it. So I can populate the hash map without having to, calculate the hash maps on the startup of the program and just put everything in there. Because I do want to have all the keywords in the symbols table as well, and I also want the things in the dictionary, so it all just simply works in the same way as with user-defined symbols, right? And this way, if you add a new keyword, right, you don't have to then go ahead and like change the enum, change all this, and and try to make it all work, because you just have the code generation that works. But now I'm kind of struggling with the code generation because it kind of bubbles out. So I'm probably overcomplicating this a little bit too much for this project, but again, I see it as a nice learning experience because I always wanted to see how I can do like, a simple code generation program like this. Ain't really simple, but that's a different issue, right? Sort of. So this is just a way to iterate over it later on. Okay. Then we check if it already exists. If it does exist, we will stop because we don't want to have it defined twice. And then if it doesn't exist, right? Okay, so at the moment, let's just full-blown return, whatever, right? Right, doesn't matter. To do error symbol type keyword. Symbol keyword is right. This is where we need the keyword number. And so far, I mean, I can probably just do this. Right. Doesn't really matter what we put in there at the moment, because that can be resolved later on. So now we populated the symbol, but we also want to make sure that right. So if first is null, then first is keyword definition. Otherwise, let's call this next keyword. Right. And this is definitions. And actually, definitions. What did I? Okay, otherwise, definitions next equals next keyword. next keyword first equals definitions first. Okay. Hopefully. Okay, let's remove this. Right. Okay, we have create output file. I mean, this can actually go in here as well. Right. Okay, let's just loop over all the definitions and then print them out and see if it actually worked, right? Definitions equals definitions first, right? And actually, if definitions is 0, then we want to print an error, right? And just fail for now. Actually, just have some kind of output. Write error output string literal right, just so we can see something. Okay, so then definitions is definitions first, and then while we're going through there, write write arrow string. Okay, sorry. And then write output string. Okay, and that will be definitions. Enum name. Yeah, let's just print the and let's print the identifier, right? For now. String literal. I need to kind of do this hacky way of the new line as a separate print, but whatever. Okay, so and then definitions equals definitions next, right? And while definitions is not null. Okay. All right. Builds. Yeah, that was expected. Oh, Jesus. Oh, type def enum. And this is type def struct. Type def struct. Okay. This is token. No. Ah, token position. Okay. Oh my god. Lordy lord. Right, definition is no longer there. This is file. Don't need to do this for arena. Okay. Next is not a member of definition token. That is true, because it's a keyword definition. What on earth did I do here? What was I thinking? The answer is nothing, probably. Definition token. Token is fine, but this should be a keyword definition. Keyword, right? Keyword definition. If keyword is null, then do something. Otherwise, first and next is this. Then we kind of go through the tokens, right? Token being that, and then we have right, okay, name this definition. Right. File dirt file name. Yeah, that is correct. That is correct. That it is not correct. Oh my lord. There we go. Builds. Okay. Identifier is not a keyword. Identifier. Yes, I should learn how to spell it. That would help. Okay. Here I'm returning the token, which is not correct. I need to return the definition. Okay, keyword gen 3.8. Right, what's wrong here? Different than the I don't need this in here anyways. Okay. There you go. Program start. Void returning a value. Whoops. That is correct. So this needs to be this for now. Okay. 7.1. Tokenizer, undeclared identifier. That would be correct. We do not have a tokenizer. Keyword gen C. Okay, U32. Assignment within conditional expression. It's a warning anyways, but let's see. Yeah, so what's the problem? Right, so if next keyword is not null. Are you happy now? Yes. Okay, error, missing new line after keyword definition. Really? Interesting. But we managed to get LD. Oh, really? I need a new line here? Okay. Now it prints LD and alias. Excellent. And now if we have alias twice, right? Actually, this can be anything, right? And then alias. That's not what I expected to see. Let's check the tokenizer again. Oh, duh. Item value equals symbol. Right. So now it prints out the error, right? I can define a proper error at some point. I'm not going to do this right now, but like, okay. So now we can specify keywords. So LD, right? I don't know, swap and swap, for example. Let's just do those two. Why is this complaining now? Keywords C. That will be the generated file. So let's make sure this is correct. No, that can't be it. What? Dot based. Dot base. Left operand points to. But. Oh, the hash map. Right. Right. Okay, cool. So now after this process, we should have enough information to then build like the enum and stuff like that. So the keywords .c and .h file, right? So header file and source file. Okay, so we want we want an output file. This will be header, right? Let's call it out header. Header file, and we want let's name it source. Source file. If out header, no, we already do that. They should be valid. famous last words. So this hash map insert here is really just a way for me to avoid duplicates. Well, and kind of to deal with collisions, right? Let's do it this way. So I don't have to count the numbers here. And then we can just say next keyword number. This is really hacky. Gotta love it. To be fair, I don't think it makes much sense to store the symbols. I mean, I can store whatever I want, right? Like, I should really just store the keyword definition in there. Then I don't need this whole thing of, like, doing this nonsense. I think that would be much better, to be honest. So in get next keyword definition already allocates on the arena, so it's already put somewhere in memory anyway, so I just need to refer to it, right? So I can just say keyword definition, right? No, I don't even need to allocate. Right? This whole thing is nonsense. Right? All I want to store is just call it keyword, right? So I'm getting the next keyword definition, right? It has an identifier, it has the number, it has the enum thing, right? I'm just trying to put this into the hash map. If it already exists, this is an error, obviously. If it does not exist, well, we just need to add this keyword, right? All of this is nonsense. Like, that was a waste of time. So, and then also don't need to do that, right? And also we can adjust this a little bit. So let's try and build the header first. Right? Build header file. So we're creating a header file, and then we just need to write into it. What do we write into it? Well, this. Right, so write. Do I have a write file thingy? I do not. I do have one in this other project, sort of. I can use write output file string. Right, let's copy this and modify this a bit. Here. We have the file handle, and then we have the message. Which is fine. Don't need that. We know that it is valid. I do not even need to check whether stuff has been written or not, because like if it has not been fully written, then the compilation will fail anyways, like later on. So this is just way more than I need to do. But okay, let's just have this. Okay, so write output file string, right? String literal. What we want to write is, how do you do multi-line strings in C? Is that possible? Multi-line strings C. But that is C++. String literal C99. There we go. I mean, I can just try, right? Whatever. Right. What does that do? Let's copy all of this in a new file. Built. Yeah, okay. Doesn't say anything about multi-line strings. I've never used them in C, so I actually do not know if that is possible or not, but I guess not. If anyone in the chats knows, let me know. Otherwise, I'm just going to do this line by line, whatever. Doesn't really matter. It's just a generation program, right? So I can just do this line by line. No biggie. Right. We can do this, this, right. Also forgot the file handle. I'll add it in a sec. Okay. So this, and then this, and then can do that. Okay. Right, and this goes into out header. Right. So now, cool. And if we look into keywords, there we go. This is the keywords. And now I can populate it with the enums of things that we're going to iterate through. So actually, I don't know if I even need the number, right? Because the order doesn't really matter. As long as count is the last one and the first one is equal to 0, that's fine. I don't even need this, right? Yeah. I actually also do not need this. Right. Okay. Build. Okay. Okay, cool. Because this is like generated code, I do not need to worry about the formatting. I mean, I kind of did the new lines. I could add like spaces in front of here if I wanted to, but it doesn't really matter, right? So whatever. So in here, we now need to populate all the enum types that we're having, right? So, and we probably also can combine that kind of with the source file already, but let's not worry about the source file. Let's just pretend it doesn't exist, and let's just pretend we're building our header, right? So this would mean we have to look at the global symbols table, right? And what we want now is find the buckets that are actually populated, right? We can do like a capacity check before that, just so we don't like just build an empty header, but it really doesn't matter for this program, right? I've already overcomplicated this way too much than it should have been, but so symbol table base, this is our buckets. And what we now can do is just for use64 bucket, right? We're starting from 0. If bucket is smaller than capacity bucket plus plus. Huzzah! Right. And then we can, I already forgot the types, which is hilarious. Hashmap bucket just has an entry, right? Okay, so we just need to check whether entry is null or not. And then we can actually read out the entry. So let me copy this real quick. Otherwise, I will switch back and forth because I forget things. Because, yeah, short-term memory, not the greatest. Okay. So this would be dot base bucket. And in the bucket, we check for entry. And if entry is not null, we have an entry, ladies and gentlemen, and then we have to do something with that entry. And for that, we are going to get the entry, right? Entry equals, actually, I can just do it this way, right? And then do the check on entry. If entry is not null, do something. And if it is not null, we want the entry item value, which we're just gonna cheekily assume is always populated with a keyword definition, right? And the keyword definition, for that we probably want to have string format. Right, this is gonna just temporary. Formatted string format. I think that's what I called it. String format with an arena. Yep, there we go. So that is the arena, and then we have this, right? And what we want is keyword type this, and that will be definition enum name dot length and definition enum name base. Right. You can also add a new line, of course, and a comma at the end. And then write output file string, out header, and we are writing the formatted string. And then we say memory arena rewind to position arena pos. Okay, we can also do something like this. Right. Can say this is equal to 0 because this is the first item and we want to make sure it is 0. Otherwise, we're just going to leave it out. Actually, we can probably say it in here. Nah, this is too ugly. So let's make it this way. That's fine. It's fine. Oh, right. True is not a thing. And is first equals. Right. Okay. Capacity y. Right. Of course, it's a pointer. Right. Okay. Did I just... Oh, rewind memory arena to position. Okay. Oh. Also need to specify which arena I want to rewind. That is true. Okay, cool. Well, that is not correct, is it? I mean, it somehow works. What? Cool. Well, that is annoying. So get next keyword definition. Why did I screw up? Huh. Uh... I'm just preparing the debugger stuff at the moment, so I can just debug the keygen. So if I do this, this should just be... What? Right, that didn't work. Nope. Oh, come on. Like this then. Right. Okay, let's close some instances. Nope. What am I doing wrong? What? How to bat. Is it without any quotation marks? I try that. Oh no, I closed the... Oh, freaking hell. Ah, man. This is... CB assembler alpha for builds. Right. Debug. Are you not correct? No. Okay. How about this? And then did I close it again? I swear to I'm all over the place, dude. Projects, GB assembler, alpha 4. Yeah, I mean, I don't really need to, but no, not run. I want debug. Yay. Okay, cool. So this will debug the normal program. And now if I say debug keyword gen, well, that didn't work out. Oh my. Okay, this is the normal one. Keyword gen. Debugging keyword gen. Thank you very much. Okay, cool. Error starting process. Why? What? Oh yeah, right. That is not. Yeah, that makes sense. Yeah. Never mind, dude. Never mind. Yeah. Okay. How about now? Yeah. Okay. No, this is the wrong one. Ah. Keyword gen. Jesus. All right. No. Why? What's now? Now you have the. Oh my god! I hate bad files. Okay. Debug keyword gen. Nope. Why do you add a space? Where do you get the space from? Is it because of this? No. Oh my. I swear. Hallelujah. Okay. Fantastic. Get next keyword definition, and then we're just gonna check what happens here, right? So F5. We don't even get there. Why don't we even get there? Because of this shiz. Okay. So we need alpha 4. Let's just plonk that in here. F11, F5, there we go. Right, base. Token position is 0, which would be correct, right? Token length is 2, which is correct. So this should be LD, right? So we're gonna jump ahead. And indeed. Okay. So what's the issue then? Identifier, LD. Seems to be fine. Okay, returning the definition. Inserting it into the hash map. Setting item value to keyword. And continue. Okay. So let's jump ahead. Definition. Enum name. LD. I have a slight suspicion. No. What? Oh. There we go. Okay, it was me being dumb with the formatting. Never mind. Okay. Well, at least we added the ability to debug that program as well, which is nice. Always good to have, right? Okay. So now we would want to write the source file, which I just deleted. Yay. Okay. Let's put that here. I mean, that doesn't really make sense, but... Okay, let's just plonk that in here. And convert that into rights. Right? So something like that, but we're gonna write into out source. And the first thing we're gonna write is include, and then we do this shebang right here, right? Can have a new line, another new line, why not? We need keyword data. Sure. right? And then we have the struct, like so, with hash map entry. Now this, the hash map entry stuff, for use types, I can actually do something quite nifty, but I'm not going to do it now. Let's just try and make this work. Right. Okay. And then we have another one of those. That will be this one. Right. And then we're adding all of the entries. And then the last line will just be this /n/n. Right. Oh, well, there's init keywords as well. Yeah, that I need to do later, more or less. Okay, let's just put the definition in here. Right. And then to do generate code. Right. Okay. 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 So write the header file, then we can immediately also write the entry for the source file right here. And that will be quite annoying to write. Jesus. Okay, formatted string format, right? Arena. And then we have all of this. And and this. And here we want to have %.star_s, right? Here we want percent LU. Right, I have to deal with next and stuff because there could have potentially been collisions, so I need to iterate over that as well. See how to deal with that. Then the value is just gonna be that, and the symbol is gonna be symbols type keyword. And right here we can just say this right here. So that means definition identifier length, definition identifier base, then entry, entry hash, actually I just realized we don't even need to carry around the identifier. I kind of store it twice now because I have the key, and then yeah, okay, I'll whatever. Entry hash, let's put this in the next line just so we can wrap our head around a little bit easier, and then the definition enum. Okay. And that goes into the source file. Okay. Cool. Reload, right? Okay, fine. And then the C file. Ah, beautiful. I mean, the code is correct. It compiles. No one said it has to be nice, right? So now we have a string literal right here, which will be baked into the executable, right? And we have the hash right here. We can also figure out which slot this is in for the init keywords later on. Swap also has the hash here. Yeah, perfect. And this keyword type swap is just basically the enum, so it will have the same value as whatever that is having. Oh, but this this null is not correct, right? Because this needs to be whatever that keyword type is, right? Okay. Yeah. You can go. You can go. It would just be easier to build it once, so let's do that. strt keyword enum string format arena, and then we have this right here. Okay, so identifier hash keyword enum, and again. Why did I run? Okay, now it's keyword type LD, which is correct. So it is load. So it is gonna be 0, and this is the first entry within that array, right? And then I should really add some new lines. Hang on, this is horrible to read. So a new line here. And two new lines here. Yeah, okay. So this is one entry, and this is the other. Why not adding a comment, this is an auto-generated file? Yeah, I could do that. Probably a good idea, you're right. I'm gonna do that in a bit. So now I need to figure out if there's a collision, how I want to bake in the next items, right? Because that should just point into whatever this entry is pointing to. So it would be something like this dot entry, right? And how do I deal with this? Actually, how do I deal with collisions? Okay, I can loop over here over the entries because I mean those will already have collisions, right? So I can do that. But I need some kind of list because I do not need to add the collisions to buckets, right? I only need the parents. So I kind of need a list in the end that I can iterate over, which just generates this kind of code. Okay. So I think it's entry next, yes. So entry equals entry next, and if there is another entry with like a collision, then we start adding that, right? Don't think there will be any collisions with those large buckets that I have right now, but you know, if I ever decrease the bucket size, this code needs to be generated again, right? Because now the bucket slots do not align anymore. So I need to handle that scenario definitely. So here we go to the next entry, but if next entry is 0, then we're gonna go into the next bucket. Okay, that just works fine. But now I need to figure out how to handle parents, right? This first thing is kind of annoying. right? Why not add, you know, why not add numbers to everything? Count doesn't need it because, like, it's just whatever the next one is, right? And just because you mentioned it, let's add that right away. This file has been auto-generated via keyword gen.exe. Um, I know this is kind of a double check, but I'll change that in a second to a do while. And then we can say get memory arena type. Okay, so here we can add the setup code. We only need this to do for the parent, right? Not for this, but oh. How do I even add next into it? So it's either 0 or it needs to be an address into the entry table, right? The entry table is specified by the index, right? So the next index would be the thing that's in that table. So okay, I really didn't realize that I'm almost 5 hours into this. So yeah, so next would always point to the next entry. So what I can do is something like next, right? No, let's say strt next, right? And if entry next is not null, what's gonna happen is string format like that, right? Otherwise, next will just be string literal const of 0. Right? Otherwise, it needs to be G keyword data. And then I don't know the next entries thing, but I can just essentially cheat a little bit by making this the index. In fact, I can do that with this as well, to be honest. It's fine. I'll just leave that. And then dot entry, right, the address of dot entry. And that would need to be index, which we already increment here. So this will already be pointing to the next element anyways, but only if next is not 0. Right? And then here we need to point to this. So this would be next length, next base. I could do it without the count, but I'm so used to using that, so well, he says, but then I get the order always wrong. But I just don't trust zero terminated strings, that is all. Okay. So now that is next. That is fine. But we want to have the setup line for this first entry, right? So what needs to happen is I want this code. So this is gonna be hash map base. This will be the bucket, which is LLU, right? And entry is keyword data. Damn you. Fine. Can just do this. So bucket and then enum length, name length and base. Okay. And then here, okay. While setup line is not 0, then setup line equals setup line next. And this is where we write it to the file. So and what we're gonna write is just setup line. Okay, what did I screw up? I'm reusing way too many too many names here. Anyways, incompatible types from char to memory arena. That is correct. It needs to be arena. Oh, yeah. Can't use const here. Again, arena. Definition, unclear identifier. Yeah, that would be true. Damn it. Okay. Okay. Are you gonna complain about that? Or is that okay? But this needs to be first. That takes a long time. That is not great. Oh, hello. Yeah, I'm gonna stop soon. See what? Oh. Alright, okay. I need to take the dog out in a second, so let's wrap this up. I wasted way too much time on this, honestly, but it's a good learning experience, so I'm not too upset about this. Wait, how come you never close this? What? Oh. That was it. I didn't make sure that next is always 0, so it probably did some funky stuff. Excellent. Okay, so I also have not done the dictionary stuff right here because I don't know how to quite handle that at the moment. The only annoying part here is gonna be with next, right? But basically, we now have a static keyword data, right, with the entries and the symbols. So this is just going to be baked in, and then we can just refer it like this and assign it to like buckets already when the program starts. The buckets are going to be in sequence, which is also nice. But yeah, now if I basically add a new thing, like I don't know, add with carry, right? Actually, can do it this way. Then there we go. We now added add with carry, which is kind of cool. So all of this code basically just so I do not have to, do this during the runtime. You could obviously do this during the runtime. You could just have, some kind of array that defines all the keywords with the strings, and then you just call your hash function, which says add symbol to hash table, right? And it is a fairly small amount of symbols, right? So every time you start up the program, it will spend some time to just, like, not even a second, right? But I don't like this kind of stuff, so I just want to do it like in a nice way like this, and so I don't have to do the hash calculation and all this kind of stuff during the runtime of the program. And I could have also written all of this by hand, obviously, but then once you change your bucket sizes, it's going to just be a mess to maintain. And I mean, in the previous assembler program, I kind of did the same thing. So this was all auto-generated, but it was actually not creating any code files. I just had a flag, like here, GBA hash slot calculation, right? So whenever this was defined, it would actually run this program right here, and then it would just spit out the code onto the console, so I can copy paste it in there. But obviously that is a manual process. I do not want to do that. So if now we just run build, right? It builds the keyword generator, it runs the keyword generator, and then builds the actual program, and it has all the keywords it needs, which is quite nice. Okay, I don't know why this is. Oh. Hang on, I screwed this up. Hang on. Oh yeah, this should be outsource. There we go. So now it says this file has been auto-generated via keyword gen. Obviously not nicely formatted code, but since this is auto-generated, we don't care, right? And yeah, that's it. Sub. Oh my god. Okay, I need to fix this bug. Missing new line after keyword generation, right? That is a bit annoying. But there you go. I'm wondering, okay, we can actually test collisions real quick. Give me a second. There. Let's just have one bucket. Right. There we go. Now next. So this is item 0. Now because we have only one bucket, everything is a collision, right? And you can see that the first entry is the one that is the parent, so to speak. And then it just refers to the next slot, which is number 1. So it points to this one. And then this next one points to number 3. And hey, will you look at that? Number 3, next one, is this one right here. And then this one, because it's the last item, it's just next 0. And then this only becomes one line, because you only need to add the parent, which is LD. There we go. And this is quite nice, because now you can experiment with bucket sizes and all this kind of stuff. Can change it on the fly if you wanted to, and do not worry about how your symbols get inserted into it. Right. So, and it builds kind of fast. Like, it's not that bad. And now we could spend some time to make this program a bit nicer, right? Like handle errors properly and all this kind of stuff. But in the end, it's just like this tiny script that needs to be executed here. So I wouldn't worry too much about it. This is already way too overblown, to be honest. I mean, yeah, if we define things twice, that might be important, right? Oh, hang on. Yeah, I should probably change this error message. Okay, make keyword gen a bit nicer. Clean up, because now it is all over the place. Add nicer error messages to keyword gen, right? So this is something we can do later, but then add all the keywords to the keyword gen definition file. And I think that is it for today. I really have to take the dog out now. So are there any questions that I can answer real quick? Or my gosh, 5 hours. And I forgot to drink water. Oh dear, that will give me a headache. I really wasn't prepared for today. But yeah, based on the stream schedule, I will continue this on Wednesday, right? And yeah, the cleanup shouldn't take too long. I mean, it's really just these few code files here. I just want to, you know, just make it a tiny bit nicer. I mean, ideally, you also wouldn't want to add like all these things, right? Actually, that's a good point. I don't even need to have symbols and stuff in here, right? I mean, I don't even need tokens. Right? The only reason why I have tokens in there is... Why do I have tokens in there? Oh, probably because of the dictionary? Okay, what if I do this? Right. Oh, this, because I'm using init global symbols table, and then, yeah, this is totally unnecessary. Like, none of this is needed. Right, so that is something I can do for the cleanup. Actually make this like a nicer, tighter program. And instead of having like referring to these, maybe I just copy it in here, so we could actually take this out as an own program somewhere, and it builds without all the dependencies to this. But I'm not sure, right? remove some of the includes. Global symbols table is unnecessary. Okay. Right, okay, that's it. I'm not going to put the source code up on Ko-fi today, but rather once Alpha 4 is finished. And again, Alpha 4, I wanted to have at least recognizing all the keywords, that are in this assembly file right here, right? And have the mechanics in there that if you make an error, like you type LDX, for example, it would say, hey, did you just mean LD instead of LDX, right? Something like that. That should all work. And then Alpha 5 would essentially just be dealing with the operands and stuff. This is where the fun stuff begins. And yeah. Okay, so if there's no more questions, then I'm going to quit it here. Thanks for watching. See you Wednesday. Bye.